Hi guys, you're welcome to Dssg Nation. So if this is your first time watching a video from Dssg Nation, do make sure to subscribe and hit the bell button so we can notify you whenever we create. So today we are going to be talking about the pituitary gland. So pick your paper and your pen and let's get started. Hi guys. Yeah, you're welcome back. So we said we are going to be talking about the pituitary gland. Pituitary gland. Now, glands are organs as well. So we are going to use our acronym for describing all organs. So I want to believe this is not your first time of watching us. So if this is the first time, just make sure you check out the video I'm going to drop ahead. That is called acronym for describing all organs. So our acronym for describing all organs is what we are going to use to describe the pituitary gland as well. So we have the B-O-L S raised to power 4 F. So the D is description, and the description contains three things. That is the system, the color, and the weight. So for the O, organ in relation. Organ in relation. The next one is the location. The S is the size, shape, structure, and the supply. So the F is the function of that very organ. Now, using this for our system, so the pituitary gland is an organ of the endocrine system, and that is that about the system. So what next? The color. The color is negligible, so you can leave it. So for the weight, it is about 500 milligram. So that is 0.5 gram. So it is about 0.5 gram to 1 gram. Now, the next one is the organ in relation. For glands, generally, you can neglect the organ in relation. No one will crucify you for that. So the next one is the location. So where is the location of the pituitary gland? Where is it located? It is located in what we call the cella tussica. Cella tussica. And this cella tussica is just a depression or a hollow space within the sphenoid bone. Within the sphenoid bone of the skull. The sphenoid bone. So that is where it is located. And some people used to use hypophyseal fossa. So why? Because this word hypophyseal, it is derived from hypophysis, and hypophysis is another name for pituitary gland. We are still coming back there. So fossa is just a hollow space, or a depression, or a cavity. So the cavity occupied by the hypophysis is what we call the hypophyseal fossa. But to be specific, it is the cella tussica of the sphenoid bone. So the next one is the size. So the size, when you measure the diameter, is going to give you about 1 centimeter. So, and that is that for the size. So, to the shape, it is a P-shaped organ, P, the shape of a P. And now to the structure, the supply, and the function. Well, let's keep the structure for now. We are still coming back there. So, the supply to the pituitary gland, since it is also called hypophysis. So, it is hypophyseal artery. Why the venous drainage? This is the arterial supply now. Arterial supply is the hypophyseal artery. The venous drainage is the venous sinus of the brain. The venous sinuses. So the venous sinuses. So, and the function now. Okay, we are going to describe the structure and the function together. So let me clean the board and then we're going into the structure to be specific. Now, before we proceed, let me quickly give a recap. For a description, is an organ of the endocrine system. Is about 500 milligram, and then it is located in the cella tussica, also called the hypophyseal fossa of the sphenoid bone, and it is about 1 centimeter in diameter. It assumes the shape of a P, and then the arterial supply is the hypophyseal artery. The venous drainage is the venous sinus. So let's go into the structure. Stay tuned. So yeah, welcome back. so we were discussing the pituitary gland. So we said we are going to be talking about the structure now. Structure. So the pituitary gland is also called the hypophysis. Pituitary gland. It is also called hypophysis. Hypophysis. So what is the meaning of hypophysis? The word hypo means below or under. So the word physis means to lie or to grow. So if you say pituitary gland is called hypophysis, it means it grows under or it lies below. So it means to lie below or to grow under. So if this is the pituitary gland now, it lies under another gland. It lies under something else. If this is your pituitary now, then it is lying under something else, or it grows from something else above. Again, there is something up ahead like this, and then the pituitary gland lies under it like that, or it grows under it. That's why they call the pituitary gland hypophysis. So what is that thing that is ahead? That thing ahead, that gland is the hypothalamus. Hypothalamus. So the one below it now is the pituitary. So this one is the pituitary now. The pituitary gland. Now, since they are linked, there must be a kind of communication between them. So I'll turn the board and then we are going to talk about the communication between the hypothalamus and the pituitary. I mean the relation between the hypothalamus and the pituitary gland. But I don't need to turn the board. Let me just quickly dish this in somewhere. Okay, let's do this please. So yesterday we said the hypothalamus is to give 5 commands. Oh, sorry, it might not be yesterday to you. So let's say in the previous class. So we talked about 5 commands by the hypothalamus. So if you remember very well, you realize that the command is directed to the pituitary. So if you have not watched our video on the introduction to the endocrine system, I will also drop a link for you. You can always go back there so you understand what I was talking, what I'm talking about rather. Now, hypothalamus now is ahead. Hypothalamus. So it has usually 2 connections with the pituitary. And the first one is the anterior connection, and the second one is the posterior connection. So now this means our pituitary will have majorly 2 parts. So the first one is the anterior pituitary, and the second one is the posterior pituitary. Now this middle part is called the pars intermedia. And in some textbooks they will call it the middle lobe. We are going to lay more emphasis on it after I rub this board off. So just stay tuned. Yeah, welcome back. So I said we will be talking about the relationship between the hypothalamus and the pituitary below. Now, if from A to A is the hypothalamus, and downward, just hypophysis, so is the pituitary. We said this will be our anterior hypothalamus, and this will be our posterior hypothalamus, which means this will be our anterior pituitary, and this will be our posterior pituitary. Now, the connection between the anterior hypothalamus and the anterior pituitary is blood vessels. So there's a capillary bed here. There's a kind of capillary bed here. There's a capillary bed right here. So the capillary bed now comes down as blood vessels. So it comes down as blood vessels into the what? Into the anterior pituitary. So within this anterior pituitary, we have some cells there. We have some cells in it that used to secrete different hormones. So the cells are 5 in number. 5 cells in the anterior pituitary. So the first one, okay, you are going to be the one to tell me. So once you've watched our previous video, you are going to be able to say this without having any kind of difficulty or any kind of problem. Now, the blood from air, it carries hormone down into the what? Into the anterior pituitary. And that hormone is going to trigger all these cells to secrete their own hormone. Yesterday we were talking about the president and the vice president. So the president is going to give one of the 5 commands, one of the main 5 commands, the G square PCT that we talked about. So, and the hormone is going to travel now through these blood vessels into the what? Into the anterior pituitary. And the hormone is going to tell the cells to secrete their own hormones. So what's the meaning of that? It means the hypothalamus is going to secrete hormones. And the hormones is going to act on the cells, either of the 5 cells, any of the 5 cells rather. And those 5 cells, so they are going to secrete their own hormones. And that is that on that. So, what are the hormones of the anterior hypothalamus? The hormone that gives command to the anterior pituitary cells to secrete their own hormones. So, what are those hormones? Yesterday we said they are the G square PCT. So, we said the first one is what? The gonadotropin releasing hormone. The second P is what? Growth hormone releasing hormone. Okay, that is G. Then the next P is prolactin releasing hormone. So the fourth one is what? G square PCT. C is CRH, corticotropin releasing hormone. And the fifth one is the T, thyroid releasing hormone. So the hypothalamus is going to give any of these 5 commands. And then the hormone is going to come downward. It's going to come downward like this. Downward. And it's going to act on these cells. And these cells too, they start secreting their own hormones. So, let's say the gonadotropin releasing hormone. Let's say the gonadotropin releasing hormone is released by the anterior hypothalamus and it acts on the cell here. So the cell is going to secrete FSH and LH according to what I told you yesterday. So now, the cells that secrete the gonadotrophins are called the gonadotropes. Gonadotropes. So, those 5 cells, the first one are called the gonadotropes. So they respond to what? They respond to gonadotropin releasing hormone and they are going to produce what? FSH and LH, which is an hormone of the what? Hormone of the anterior pituitary. So these hormones are for the hypothalamus. So in response to gonadotropin releasing hormone, the gonadotropes are going to secrete FSH, follicle stimulating hormone, and LH, which is luteinizing hormone. We talked about all this yesterday. Now, 2, let's say the anterior pituitary, it gives another command, which is GHRH, growth hormone releasing hormone. So the growth hormone releasing hormone is going to come down as well and act on one of these cells, and that cell is going to secrete growth hormone. And the name of that cell that produces the growth hormone, so it's called the growth hormone somatotropes. Somatotropes. So yesterday we were talking about somatotropin and somatostatin. Sorry, I keep saying yesterday. So just go and watch the previous video. So the somatotropes, they are the one that secrete what now? The growth hormone. So the growth hormone is the second hormone of the what? Of the anterior pituitary gland. So let's say the third one now. Okay, that is for G2. So the third one now, the PRH3. So the prolactin releasing hormone. If the anterior hypothalamus secretes prolactin releasing hormone, it's going to come down through the blood vessels as well, and it's going to act on one of these cells. And what are the name? What is the name of the cell rather? So those cells that are going to secrete prolactin, they are called the lactotropes. Lactotropes. So they are going to secrete prolactin, PRL. So then the C now, fourth one, the C. So the C is the CRH. So in the anterior hypothalamus, if it releases the CRH, the CRH, is going to act on one of the cells, and those cells are called the corticotropes. So the corticotropes are going to release what now? Adrenocorticotropic hormone. And now the fifth one is the what? Is the TRH. So the anterior hypothalamus releases thyroid releasing hormone. It's going to act on this cell by traveling from this through the blood vessels into this place. And the cell that used to secrete that are called the thyrotropes. So these are the 5 cells of the anterior pituitary, and these are what they used to secrete. So the gonadotropes, they used to release what? FSH and LH in response to what? To the gonadotropin releasing hormone. And the second one is the growth hormone. They are secreted by what? The somatotropes in response to what? In response to growth hormone releasing hormone. So the next one is the lactotropes. The lactotropes, they used to secrete prolactin in response to PRH from the hypothalamus. So, and the next one is the corticotropes. So the corticotropes secrete ACTH in response to what? To CRH. And the last one here is thyrotropes. So they secrete thyroid stimulating hormone, TSH, in response to what? To the TRH. And that is the relationship between the anterior hypothalamus and the anterior pituitary. So, because the anterior hypothalamus contains glandular cells that secrete, so they used to call it adenohypophysis. But I'm still coming. Let me just drop the word and talk about it. Okay, before that, let me quickly come in with this. Okay, let me just quickly go and come in with everything all together. Stay tuned. Yeah, welcome back. So, a quick recap. We said if this is the anterior hypothalamus and this is the posterior hypothalamus. So we are using the W. Okay, I want this one to come down a little bit because I'll be talking about this now. So, and this is the posterior pituitary now. So we said the anterior hypothalamus rather, it has a connection with the posterior, with the anterior hypothalamus, with the anterior pituitary rather. So anterior pit. And then the posterior hypothalamus also has a connection with the what? With the posterior pituitary. So we said the relationship between these is just that blood vessel. So the blood vessel runs from here to the what? To the anterior pituitary here. So it activates some kind of cells to secrete their hormones. So we said there are 5 cells and the anterior pituitary. We talked about the gonadotropes. We talked about the G square. The first is gonadotropin releasing hormone. So gonadotropes. So second one is growth hormone. So they are the somatotropes. So the next one, P, that is prolactin releasing hormone. So those are the lactotropes. So G square P, then the C is CRH. So the C is corticotropes. So the next one are the corticotropes, and the last one, PCT, thyrotropes. They release thyroid stimulating hormone. So those are the 5 cells of the anterior pituitary. So because this anterior pituitary, it contains glandular cells, it is called adenohypophysis. So we already know that the hypophysis is pituitary gland, but the word adeno means gland, so it means glandular pituitary. So the part of the pituitary that is glandular in function, so it contains glandular cells. That's why they call the anterior pituitary adenohypophysis. So now to the posterior pituitary. Now this posterior pituitary, it is made up of nerves. Posterior pituitary is made up of nerves. So, nerves. You can just watch our video on neuron and then you're going to understand what I'm doing here. Now, the posterior hypothalamus, it has 2 nuclei, 2 major nuclei. So, nucleus is the singular. So, it has 2 nuclei. So, these are the 2 nuclei now. This one and this one. You realize that this cell body is within each nuclei. Each nucleus rather. Now, the first nucleus is called the supraoptic nucleus. So the second one here is called the paraventricular nucleus. Now, what is the function of this supraoptic nucleus and the paraventricular nucleus? For the supraoptic nucleus, the cell body of the neuron that is within it, it used to secrete an hormone called ADH. So the supraoptic secrete the ADH now. The cell body within the supraoptic nucleus, this cell body used to secrete ADH. So ADH is antidiuretic hormone. Antidiuretic hormone. So this paraventricular nucleus, the cell body within it used to secrete what we call oxytocin. oxytocin. So after secreting it into the cell body, it is going to travel down like this through the axon of the neuron, and then it is going to be stored in the posterior pituitary. So same thing with this as well. It's going to carry it downward into the what? Into the synaptic nerve, and it's going to be stored in the what? The posterior pituitary. So this means the posterior pituitary has no secretory glands like the anterior pituitary. So the posterior pituitary is only storing the hormone coming from the posterior hypothalamus, and those hormones are the what? The oxytocin and the antidiuretic hormone. So the oxytocin is produced by the paraventricular, the cell body in the paraventricular nucleus, and the ADH is produced in the cell body inside the what? Inside the supraoptic nucleus, and that is that about that. So now let's talk about the hormones one after the other. So I'm going to clean this and talk about it. So stay tuned. Yeah, welcome back. So we said we are going to be talking about each hormone. Now we've highlighted 5 hormones for the anterior pituitary, and we've highlighted 2 hormones for the posterior pituitary, So 5 for the anterior. Now, to describe these hormones, we have to bear some things in mind, because we are expected to talk about some things. And those things, the first one, okay, let me just split it here. We are expected to talk about the initiator hormone. And the next thing I am expected to talk about is the cell that secretes it. So, and then the next one I expected to talk about is the site of action. And then you are going to talk about the inhibitor hormone. Now, I know you don't understand what I'm talking about, but don't worry, after giving you like 2 examples, you will comprehend it very well. Now, anterior pituitary, we said we have the gonadal tract that secretes FSH and LH. FSH and what? And LH. So if you want to talk about the FSH and LH, you are going to start by talking about the initiator hormone. So how do you do that? What is the initiator hormone? The initiator hormone is the hormone that initiates the production of this hormone. Now don't forget, the anterior pituitary is a vice president from our previous class. So it is responding to a command from where? From the president, which is the hypothalamus. So the initiator hormone is the hormone that acts on the anterior pituitary to cause the secretion of these 2 hormones. So if you want to talk about FSH, you are just going to say the gonadotropin releasing hormone from the hypothalamus is the initiator hormone. So and it acts on the anterior pituitary. And now after that, you talk about the cell that secretes it. So the cell that secretes it is what? The gonadotropin. You are going to say they are secreted by the gonadotropins. And now their site of action. Where are they going to? So they act on the ovary and the what? And the testes. They act on the ovary and the testes. And lastly, I expect to talk about the inhibitor hormone. What will stop the secretion of that hormone? And that is what? High levels of this hormone. Majority of the hormone, I said that in our previous class. When they rise, they fall back themselves. Just like the thermostats of your house. So that is that the message. So the next one now. So G square, these are the gonadotropins. Then the next one is somatotropins. That is growth hormone now. So the next hormone is the growth hormone. So if you want to talk about growth hormone, you say the production is stimulated by what? The initiator hormone, which is what? The growth hormone releasing hormone. Then you go to the next one, you say that secretes it. So and you say it is secreted by what? By the somatotropins in the anterior pituitary. Now, site of action. So the site of action is the body tissues, especially the muscle and the bones. So that's the site of action. And then the next one is the inhibitor hormone now. So the inhibitor hormone is the somatostatin, the growth hormone releasing inhibiting hormone that we talked about yesterday. The 2 other commands apart from the G square PCT. So all these things might look difficult if you've not watched our video on introductory aspects to the endocrine system. So let's proceed to the next one now. The third one now is the what? G square P prolactin releasing hormone. So that is the prolactin itself, the PRL. So what is the initiator hormone? The initiator hormone is that hormone produced by the hypothalamus, which is what? The PRH, prolactin releasing hormone. So then what next? Cell that secretes it. So it is secreted by the lactotropes of the anterior pituitary. So next thing, site of action. So it acts on the breast. So it acts on the breast to produce milk. So the next one now is what? The inhibitor hormone. So the inhibitor hormone is the prolactin inhibiting hormone, PIH, and that is what? That is dopamine. So, and the next one, the first one now, PCT, C corticotropes. So that is ACTH now. That is the next one. So this ACTH now is talked about the inhibitor hormone. So the inhibitor hormone is what? The CRH, corticotropic releasing hormone, coming from the anterior pituitary. So the next one is what? The cell that secretes it. So which cell secretes ACTH? They are the corticotropes. So they are secreted. They are going to tell them that they are secreted by what? The corticotropes of the what? Of the anterior pituitary. So the next one is what? The site of action. So the site of action is adrenal cortex. Adrenal cortex. So the last one now, the inhibitor hormone, high levels is going to bring about the inhibition. So that's exactly that. Now the fifth hormone now is the what? G2PC. So the T is the thyroid stimulating hormone here now. The thyroid stimulating hormone, the TSH. So the initiator is what? Thyroid releasing hormone coming from the anterior hypothalamus. And then the cell that secretes it is what? They are the thyrotropes of the anterior hypothalamus. Then you talk about the site of action. So you said they act on the thyroid gland to secrete T3 and T4. The thyroid gland. So and lastly, inhibitor hormone. So high levels used to shut it down. And that is that about the what? About the anterior pituitary. Also called the what? The adenohypophysis. Why? The word adeno is gland. So the glandular part of the pituitary is the adenohypophysis. So now to the posterior pituitary. The posterior pituitary is also called neurohypophysis. Neurohypophysis. Hypophysis. Why? Because neuron is the one that binds the posterior pituitary with the anterior pituitary. So the relationship between the posterior and the anterior pituitary and the anterior the posterior and posterior, the posterior and posterior pituitary is the neuron. So that's why they call it the neurohypophysis. So the posterior pituitary, we said it produces oxytocin. Oxytocin. So now there is trouble we used to encounter as students. So we are going to be trying to remember the nucleus that secretes oxytocin and the one that secretes ADH. But it's very simple. Just when you remember the PAORA, PO, so PAORA, you are going to remember the nucleus that secretes oxytocin. So it is the paraventricular nucleus. So for ADH, once you remember the SA node from your CVS. So your S and your A. Your A is ADH. That S is the supraoptic nucleus, and that is just the code. Now, what is the function of oxytocin? The function of oxytocin is to bring about contraction. Contraction of what? Contraction of muscles, such as the uterine muscles during labor, uterine muscles, and then the myoepithelial muscle of the breast as well. Myoepithelial muscle. Okay, myoepithelial tissue rather, not muscle anymore, because myo denotes the word muscle before. So the myoepithelial tissues of the breast. So oxytocin helps in contraction of these muscles, the uterus during labor, and then the myoepithelial tissue of the breast during breastfeeding. So the last one, ADH. ADH is called antidiuretic hormone. And what is the meaning of that? Just from the word anti. Anti means against. And then diuretic. The word diuretic is from the word diuresis, which means excessive loss of water. Loss of water. So hormone. So antidiuretic hormone. So it's a hormone that works against loss of water. That hormone prevents the loss of water. So that is the function of the ADH. It's also called vasopressin. So it increases the blood pressure. It increases the blood pressure rather. So again, oxytocin helps in contraction of what? Of muscles, such as the uterine muscle during labor and myoepithelial muscle during breastfeeding. So for this ADH, it is also called antidiuretic hormone and also called vasopressin. It is called antidiuretic hormone because it prevents the loss of water, and then it is called vasopressin because, let me write it, vasopressin. Vasopressin. It is called vasopressin because it increases the blood pressure. So let's just quickly talk about the inhibitor hormone, or something that can inhibit ADH, or something that can prevent it from performing its function. And then we call it a day for this class. So stay tuned. Yeah, welcome back. So I said I want to talk about the ADH, antidiuretic hormone. So we have a unit in our body called the nephron. So nephron. So this nephron is responsible for uropoiesis, that is urine formation. So the ADH hormone, antidiuretic hormone, it prevents loss of excess water. It prevents loss of water in urine. So water is supposed to come out like this. So H2O. So the water is supposed to go out. But the ADH is going to act on the nephron and draw back the water into the what? Into the blood to maintain the blood volume. That is the function of the ADH. It acts on the nephron and drain out the water from the nephron, thereby preventing it from going outside. So, but in people who take alcohol, so alcohol is that very substance that used to prevent the function of ADH. So when they take in alcohol, alcohol used to prevent ADH from performing its function, and that is the reason why people that used to drink alcohol used to urinate a lot, because the function of the ADH cannot be maintained anymore. So instead of the ADH to reabsorb the water into the bloodstream, there is nothing to do the function to do the reabsorptive function. So the water is just going to be lost in urine, and that's why people who take alcohol used to urinate more often, because alcohol is going to prevent ADH from working. And ADH is supposed to draw the fluid into the bloodstream, but the fluid will be in their nephron with nothing to bring it back, and that is going to lead to the escape of the fluid in urine. So that is one. So we said ADH is also called vasopressin. Vasopressin. So and I said the function of vasopressin, ADH as well, is to do what? Is to increase the blood pressure. Increase the blood pressure. The blood pressure. So here, we all know that blood pressure is associated with vasoconstriction. So when the vessel is constricted like this, if this is the normal size of the blood vessel now, this is our normal size now, the NS, the normal size. So when constriction sets in, it's going to become like this, and it means the volume of this blood vessel has reduced. The volume here will be high. You can't compare the amount of blood inside this vessel with this one. So the volume has dropped here now, which means the pressure is going to shift up according to vessel law. We have not watched our last one and watch it. You understand what I'm talking about very well here. So when someone takes alcohol, instead of the vessel to constrict, reversal will be the case. The vessel will be dilated, and that will lead to inadequate blood supply to the brain. And that is what brings about the dizziness in alcoholic patients, or don't let me call them patients, in people who used to take alcohol. So, like, just imagine now, this is the normal size of the blood vessel that vasopressin has acted upon. So imagine that the blood inside this place is up to this level. Now imagine that this vessel becomes dilated. The level of this blood is going to drop. So it won't be able to supply the brain very well. And that is what causes these stagnant movements and these zigzag movements in alcoholic patients. Okay, in people who used to take in alcohol. And that will just be the end of our class for endocrine system for today. So in our next class, we are going to be talking about the thyroid gland. So if you enjoyed this video, just make sure you give it a thumbs up, and then make sure you subscribe if you have not. And if this is your first time watching a video from this Dssg, just make sure you subscribe and hit the bell button so you can always notify you about new video.